Okay, so now let's go ahead and update these definitions for the full vector treatment. So we can start with position, and now we need to define position as a vector. So the position is going to be written as r, as we've been using it before. This is going to be the position with respect to some origin, and we would write this as the x-coordinate in the i-hat direction, plus the y-coordinate in the j-hat direction. And if we have z, we could write this as the z-coordinate in the k-hat direction. So our three unit vectors are i-hat, j-hat, and k-hat, which point along the three coordinate axes. And so just like we had position in the one-dimensional case, position needs an origin in order to define where we start. And we have to define the orientation of the coordinate axes. So we need a plus and minus direction for our axes in order to specify where we are in space. So that's the first of our new definitions. The second thing that we can define is distance. And distance is literally just the distance from the origin. So you can think of this as the magnitude, the length of this vector r. So distance is the magnitude of r, and that's just going to be equal to the square root of x squared plus y squared plus z squared, where those are the coordinates of the object that we're looking at. And so this is a number. It does not have a direction. It'll have units, but it will not have a direction. And it really is just the length of r. It's the distance between the origin and the coordinate point that we're trying to specify. So those are the first two. And now we're going to move on and complete the sequence.